Hi there, my name is Mark, and today I'd like to share with you how I make use of snippets to write LaTeX code in Emacs. Now for this, I'm making use of two packages. The first is Yasnippet, and it is a popular text expander for Emacs, and I use this for my more complicated snippets. And in addition to this, I also make use of Auto Activating Snippets, the package, and there is a more specific one designed for LaTeX, and it is called LaTeX Auto Activating Snippets that I make use of quite a bit. Now we're going to get to see how I can use some of the built-in snippets and how I have defined some of my own snippets to increase the efficiency that I'm able to write LaTeX code. So let's just get into the examples and let's get teching. So today we're going to be taking a look at two amazing Emacs packages for snippets. The first is Yasnippet, and the second is going to be the Auto Activating Snippets package. And this is going to be specifically for LaTeX code. But let's get started with Yasnippet, and we'll start off with an example, which is a quadratic formula. So I'm going to start with a key binding here of M for math, A for algebra, F for formula, followed by a Q. And you can see here that I can choose quadratic formula from the completion menu, and that is just included that block of code into my buffer. Now let's make it a little bit more interesting this time. I now want to be able to substitute the values of the parameters into the quadratic formula. So I'm going to go M, A, F, and this time I'm actually going to type QS for quadratic substitution, and then I'm going to hit Tab, and that brings my cursor into the first field where I can enter the value of the parameter. And then I can tab through the remaining fields and update those parameter values, and eventually my cursor is placed in a position where I could continue solving this quadratic equation. Now, how did this work? How did I get Yasnippets working with Doom Emacs? Well, the first thing we're going to do is go into my init.el file. And here we just need to make sure that snippets under editor is uncommented. And the other thing that I've done here is at the top here under completion, I've activated company and I've added the module of child frame. And what that's going to do is enable me to see the actual code that will be expanded into my buffer. So here you can see for BS, you can actually see that this is a Beamer section. Or BSA for a line. I can actually see the code that will be expanded into the buffer. So here I have my align environment. All right, so where are these snippets coming from? Well, let me dive into my config.el file and let's look up snippets. Now, let's see, let's scroll down a bit here. There it is. So I don't have a lot of customization, but one of the things that I do call after Yasnippets is loaded is I define the directory where my snippets are located, and that's somewhere on my Dropbox. In fact, I'll navigate there in just a moment. The other thing that I enable by default is nested snippets, and this just allows me to run snippets within snippets. Okay, so let's navigate to my Dropbox, my .files, .doom.d, snippets, and LaTeX snippets. And here you can see the directory where all my snippets are stored. This is just so much better than a VS Code JSON file. So let's navigate into that quadratic formula where the substitution is taking place. You can see the key here, MAFQS, and then I've actually gone ahead and defined the snippet. Now I'm not going into the specifics of how to construct a snippet. In fact, there is an amazing video by Jacob B who will take you through that process, but here you can see I'm using a fairly standard notation that is used in TextMate and VS Code for defining the fields that will be populated as you tab through the snippet. Okay. Let's get back into our document here. And another snippet that I use quite often is for systems of equations. And in this time, I'm going to use the snippet M followed by A. That should be A, let's backspace A, and E for equation, and then SE for system of equations. And you can see here that I have an environment as well that's not very standard, is it? It's called syseqn. So I have expanded a snippet for an environment that I've actually custom defined. And to take a look at where this exists, I'm going to go into my techmf directory here, and I believe I have MHO macro. So I have a specific macro defined where I define this command for system of equations, and basically it sets this up for me, and it makes use of the dcases environment that I could never remember. And essentially this just allows me to incorporate fractions if I need to into my systems of equations, and I can start writing right away. Another thing I use this for is for citing questions in books that I often use, so textbooks, and these are customized, so I also am able to provide an index value. I use this for tables of values, so TBL, and I can't wait to get my derivative tables in here, so make that a little bit easier to work with. I use this for defining mini pages. So for example, if I have two cases in a math problem, I just go MP2, I can tab in there. I've got, case 1, case 2 already set up with align environments, which is super convenient. And I also use Yasnippets to do things that are just so monotonous, like finding the value of the slope given 2 points. So here, I can just go ahead, enter these ordered pair values of the 2 points, and there it is. I am well into finding the value of the slope. And I even use this for templates. So for example, if I have a new file where I'm creating a TXZ image, I can just type in T for template and start typing TXZ, and I get this template. All right, let's talk about these auto-activating snippets. This is where the real speed increase is going to come. So for example, when I type in J followed by F, I automatically am brought into an inline math environment. You can tell this was Vim inspired, and then I can just tab out and continue writing. So this snippet automatically happened. It's super quick and efficient. Now let's go ahead and see where this comes from. And all this is a snippet, JF, and you can see that it's just calling an arbitrary lambda function here, which is interactive. And take a look here. This is actually a Yasnippet that I'm executing, but it's happening automatically. And the notation is the same as it would be when creating this snippet as a standalone file. Now let's go ahead and try some of the default snippets here. So I'm going to use SR for a square value and a CB for a cube value. Notice that these are only available in math mode. So if I type XSR, no expansion happens automatically. So it only happens within the math environment. Now let's say you're in an align environment and you want that ampersand equals. I just press equals equals, and there is ampersand equals. Super fantastic. And this is one of those built-in snippets. Now scale delimiters. Now this one I'm going to use the following or. Those are 2 Swedish characters, and that is going to bring up the mpar command where I can provide it that argument. So where did this come from? Well, I defined this snippet as or, and again, it is just an arbitrary lambda function that is calling a Yasnippet, which is using a custom function. And remember, those custom functions I have in my TechMF folder here under delimiters. I have mpar, and this automatically creates those scaled delimiters for me. We also have less than or equal to's, greater than or equal to built in, plus minus command built in, and a bunch of custom functions. So for example, trigonometric functions, trigonometric inverses, logarithmic functions, those are automatically built in. And you can customize your own functions. So for example, I use LG for base 10 logarithms here in Sweden, and there you see I have been able to easily create that snippet. Notice that this one doesn't even require Yasnippet to execute. All right, let's get back into our main document where I can show you some more quick snippets here. Special characters, we're going to use semicolon lowercase a, semicolon uppercase d, semicolon lowercase p, and semicolon 8. It's never been faster. Tricky snippets, xi, x1, x2, and this subscript takes care of itself. We can even wrap an argument in a LaTeX command such as apostrophe B, and that will be placed inside the math boldface command. Custom functions, fx, gx, hx, it's super quick and it's custom. Custom derivatives, d1, d2 using Leibniz notation, fpx and fppx for Lagrange notation for derivatives, custom integrals. So I'm going to use the Swedish character ä followed by I for integral. This is the indefinite integral. And I can do something similar for the definite integral, except this time I'm going to use 2 consecutive Swedish characters of ä followed by I, and I can get right into expanding this definite integral. Now, if I want to evaluate a definite integral, I'm going to use a triple Swedish character ä and followed by I, and you can see I've got a custom function here that I am providing the arguments through the fields, and it is done. If I have an align environment and when I get to the end of the line I need those double backslashes, I just type in JG and there is the double backslash. Roots, super quick. I just use s for square root of 4, s for the cubed root or nth root, and s for a set of terms. It is so amazingly quick. I also use the SI unit X package for units. So let's get in there. I'm going to create an inline math environment, UU. I put in the value, the units, in this case, maybe meters squared. I can't keep up. I need to come up for air. So let me do this one last one, the absolute value function. I'm going to use Swedish character ä followed by a for the absolute value. Provide the argument, tab out. It's super fantastic. One last Yasnippet here as we're talking about absolute value. M for math, F for function, ABS. Let's throw in the snippet here. Expand. There's the argument x minus 3. There we have it. Snippets, Emacs. My name is Mark. Thank you for watching.